Alright, question number 1. What is the difference between a relation and a function? Well, a relation is a set of ordered pairs, such as here's one with just two ordered pairs, that's a relation. And a function is also a relation, it's a set of ordered pairs, but no two ordered pairs have the same first element with different second elements. In other words, here's one that's not a function. So as you can see, we have two ordered pairs with the same first element, number 1 here, but different second elements, or coordinates, 2 and 3. So in other words, when x equals 1, y could equal 2 or 3. So that is not a function. So a function, again, is a relation. It's a set of ordered pairs, but it's a special kind of a relation. Number 3, why does the vertical line test tell us whether the graph of a relation represents a function? So if a relation is not a function, then it contains at least two ordered pairs which have the same first coordinate but different second coordinates. So, for example, if we drew a picture of a relation which is not a function as a graph, and let's pick two ordered pairs that it has. Let's say it's got x, y1, here's y1, and x, y2. Here's y2, and let's say that's x. So we plot those 2 points. And x, y2. Again, this is not a function because it has at least two ordered pairs which have the same first coordinate, which would be x, but different y coordinates, which would be y1 and y2. Now, if it's got the same first coordinate x, it's going to lie on a vertical line y equals x. So what we have here is 2 points on this relation which lie on this same vertical line, y equals x. So the vertical line test shows us that it's not a function because it hits, so to speak, it hits the points of this relation more than one time. So in other words, there are at least 2 points in the relation which have the same x coordinate but different y coordinates. Therefore, not a function. So if it is a function, no 2 points will have the same first coordinate but different second coordinates. So that means that no vertical line will intersect the graph in 2 different places, like it does here. Problem number 5. Why does the horizontal line test tell us whether the graph of a function is 1 to 1? Well, first of all, what's a 1 to 1 function? It's a function such that if different x coordinates are paired with different y coordinates, well, that's 1 to 1. Alright, so in other words, you have different x coordinates, but if you have the same y coordinate, for example, if you have 1, 3 and 2, 3, this is not 1 to 1. Okay, This is in fact 2 to 1 so far, what I've got written here. These two x coordinates are paired up with the same y coordinate, so you would call that 2 to 1. We don't actually use that as an official term, but that would be an informal way to describe it. So this is not 1 to 1. So if you have something like this, where you have different x coordinates but the same y coordinate, then a horizontal line, if you visualize this, you have two different x coordinates, same y coordinate, right? So plot it here and here. You draw a horizontal line through. It'll touch those in more than one place. Touch the graph of this relation, that is, in more than one place. So, for example, 1, 3 and 2, 3. Draw a horizontal line. It touches this relation in more than one place. So this is not a one-to-one function. Now if the function is one-to-one, no 2 points will have different x coordinates but the same y coordinates. So no horizontal line will intersect the graph in 2 different places. Okay? Problem number 7. Determine whether the relation represents a function. So we have 3 points, A, B, B, C, and C, C. So there's our relation, consists of 3 points. Is this a function? Well, a function, if it's not a function, you're going to have ordered pairs with the same x coordinate but 2 different y coordinates. But I don't see that here. Okay, the same x coordinate but 2 different y coordinates. Okay, that wouldn't be a function. But no 2 ordered pairs here have the same first coordinate but different second coordinates. Alright, so it's definitely a function. Okay, problem number 9. We have to determine whether the relation represents y as a function of x. So the strategy on these problems is to solve for y. So we have y equals x squared as our first one. Well, there's nothing to solve here. It's already solved for y. So this is a quadratic function. If you look at the toolkit functions on page 16, you'll see that. And it has the graph of a parabola, which passes the vertical line test. Also, when you square any x value, the result is always one y value. You're not going to get 2 different y values. So this is a function. Problem number 11. We have 3x squared plus y equals 14. So we need to see if this is a function of x. So we solve it for y. Subtract 3x squared from both sides. So you've got y equals negative 3x squared plus 14. Or you could have 14 minus 3x squared, which would be equivalent. Alright. Well, what is this? This is actually a quadratic, and it's a function. All right, quadratic function of x, and it's a parabola, so definitely a function. Number 13, y equals negative 2x squared plus 40x. Well, this is already solved for y for us, so this is a quadratic. Again, it's a parabola, and it's a function. Problem number 15. We have x equals, fraction here, a rational function, 3y plus 5 over 7y minus 1. What we need to do is solve this for y. So the first thing you want to do is somehow get the y's over on one side of the equation and the x's on the other side. So first thing we can do is multiply both sides by this denominator. X times 7y minus 1 equals 3y plus 5 over 7y minus 1 times 7y minus 1. So I multiply both sides by 7y minus 1. These will cancel. 7y minus 1 over 7y minus 1 equals 1. So what you have is 1 times 3y plus 5 equals 3y plus 5. Alright, now I'm going to distribute this through the x here. 7x, x times 7y is 7xy, or 7yx, but multiplication is commutative, so I can make it 7xy. It's equivalent. Minus 1 times x is minus x, equals, now we just have the 3y plus 5. Now how do you get the y's to one side and the x's to the other? Well, you can move this x to the right and move this 3y to the left. Alright? So we can subtract 3y from both sides and add x to both sides. Okay, I'll do it in 2 steps. Subtract 3y on both sides, 7xy minus x minus 3y equals 3y minus 3y is 0, so you just got the 5. Alright. Now, I want to get this 3y over to, or rather the x over to that side. Alright, to the right side. So I add x to negative x, that gives me a 0. So that gets rid of this, negative x. Add x to that side as well. So you got 7xy minus x plus x is 0, so I'll just put the minus 3y equals 5 plus x, or x plus 5, either way. Well, how do you isolate the y's here? Well, what you do, you got a y in here and a y in here. You can do common factoring, remember that? Common factoring. Common factor the y out of these two terms. Y parentheses 7x minus 3 equals 5 plus x. Alright, don't forget to put the parentheses around the full expression here, around these two terms, otherwise it's incorrect. Why? Because if you didn't have the parentheses, you'd be multiplying the y times the 7x, but not the y times the minus 3, and you wouldn't get this back. So this line should be equivalent to the previous line. Alright. Okay, so now I want to get the y by itself, so I divide both sides by 7x minus 3. So y parentheses 7x minus 3 divided by 7x minus 3 equals 5 plus x over 7x minus 3. So divide both sides by 7x minus 3. this 7x minus 3 over 7x minus 3 equals 1, so you can cancel that out. That leaves me with just y, which equals x plus 5 or 5 plus x, either way. Usually we put the variable first. That's just our little custom in math. All right. So y equals x plus 5 over 7x minus 3. And yes, this is a function. All right. So if you were to draw this, and you'll be practicing rational functions, this is what's called a rational function. It's like a rational number. A rational number, of course, is a fraction. All right. So this is like a fraction, but with variables in it. Okay. So if you were to graph it, it looks something like that. Actually, this should be down more. All right. Problem number 17. We have y equals 3x plus 5 over 7x minus 1. Well, this is already solved for us, so there's no problem here. And this does have a graph which is similar to that of problem 15. So, and it is a function. Number 19, we have 2xy equals 1. Okay, multiply, or rather divide both sides by 2x, so what I want to do is isolate the y on one side, so 2xy over 2x equals 1 over 2x. Divide both sides by 2x, that way what you have here is 2x over 2x times y, which is equal to 1 times y, which is equal to y, right? So we cancel these out. And now when you cancel, remember that what you're doing is you're ignoring a factor of 1 when you cancel. See, this is really equal. Let me go over here to some scratch paper here. 2x over 2x times y, that's what this is over here. All right? So when you cancel, what this actually equals is 1. It doesn't equal 0, all right? So when you think of canceling, some people might think, well, it becomes 0, right? It's not there anymore. It's gone. It's 0, all right? Well, no, because 0 times y is 0, not y. So you can't think like that, okay? So that's why when you say the word cancel, some teachers, professors, don't like that word because it makes students think that you're making it vanish or vaporize and turn to 0. All right, so it's not equal to 0, it's equal to 1. And 1 times y equals y, so this is a factor equal to 1, 2x over 2x. So canceling again is ignoring factors of 1 in your equation. All right, so this is y equals 1 over 2x. There you go. All right, solve for y. You could also write that as 1/2 times 1 over x if you wish. That would be correct. That would be equivalent. All right. Now, y equals 1 over x is basically a reciprocal function. All right, and this, you have a constant times the reciprocal function, it's still a reciprocal function. Okay, so look in your toolkit functions on page 18, you'll see that example. So again, this is a function. Okay, problem 21, y equals x cubed. So this is a cubic function. Look at your toolkit functions on page 16, and this is a function. Problem 23, we have x equals plus or minus the square root of 1 minus y. So the positive and negative square root of 1 minus y. To clear this radical, we square both sides. So what we get is x squared equals 1 minus y. Alright? What happened to the negative? Well, when you square a negative, you get a positive, right? So you could think of it like this. Just looking at the negative part, ignore the positive here. That negative square root of 1 minus y squared equals negative 1 times square root of 1 minus y squared. Oops, pardon me. That square shouldn't be there. Outside. And this times this, when you square each of these. Alright, each of these factors. So that equals negative 1 squared times square root of 1 minus y squared. Negative 1 squared is positive 1, so what you get is just the square root of 1 minus y squared, which is 1 minus y. And of course, if you square the positive square root, you get a positive result here. Or you don't have to put a negative in front. Alright, so we've got x squared equals 1 minus y, and you can move the y over to this side, move the x squared over to that side. So, or in other words, you add y to both sides and subtract x squared from both sides. So you get y equals 1 minus x squared, or negative x squared plus 1 if you prefer. That would be the more conventional way of writing that. And so here we are with our familiar quadratic function, which is a parabola again. Alright, so that is a function.